Hi, today I'm going to talk about a CGA Shape Grammar editor that I wrote. So first of all, what is a CGA Shape Grammar? CGA stands for Computer Generated Architecture, and the CGA Shape Grammar is a language developed by Pascal Mueller and Yoav Parrish to describe architecture through a series of rules. It's been integrated into the CityEngine package, which is sold by Esri. CityEngine is a 3D modeling package specifically designed to easily create large cities. It can generate road grids and city blocks, divide those blocks into land parcels, and then put procedurally generated buildings onto those parcels. Today I'm talking about the CGA Shape Grammar part of it, which is the language used to generate the buildings. As someone who loves architecture, I love the idea that you can define buildings through a series of rules and then parameterize those rules to create a variety of similar looking buildings that are all different. And just to be clear, I didn't write CityEngine and I have no relationship with them. I just like what they've done and I thought it'd be fun to make my own mini version of it. So let's get into it. This is a tool that I wrote that parses CGA Shape Grammar and produces a real-time preview of the resulting shape or building. It implements just a small subset of the full CGA Shape Grammar. I've tried to get the 20% of the functions that are used 80% of the time. So it's got three parts to it. There's the text editor here, where I can type my rules. There's the lot editor here, where I can define the shape of the building lot that the building will sit on. And then there's the preview window here. So as I mentioned, CGA Shape Grammar is a rules-based language. It defines rules to change one shape into another. So in my editor, there's always one initial rule called the lot. It's defined by the lot editor here, and it's hidden at the moment. So let's create a rule here to transform our lot into a basic shape. Okay, so it's copied the lot shape, and now we can see it. I'm going to stop it from rotating. But it's fairly boring at this point. So let's extrude it. So there we go. Now we can see it for what it is. It's at least looking a little bit more like a real building. Let's break it into floors. We'll take the base shape, which was created by that, and we'll split it in the Y direction. We'll say approximately every 4 meters, turn that into a floor. Now we can't actually see anything that happened there because all the floors are identical at this point. All I can do is tell you that it's actually been split up. But let's try and scale it so we can see what's going on. Let's see, scale 1, 1, 1. Now that actually just scaled each floor into a 1 meter by 1 meter by 1 meter cube. That isn't really what we want. We can do relative scaling by using the single quote parameter. But once again, this doesn't help us. So let's actually give some random variation to each floor. So we'll give it a random variation in x by between 1 and 1.4 relative scale, and in z by random between 1 and 1.4. So now we've got something interesting. You can see they're all scaling from the origin. So let's center those in the xz direction. And we've got something that kind of looks interesting. It's not a building, but it's kind of interesting. So one neat feature of the editor is that you can hold down the control button while you're scrubbing over a value, and you can change that value just by scrubbing, which is kind of neat. You can actually change almost any value here. Oops, that one. Oh, there we go. So we're changing the size of each floor, and then we're changing the size of the building. And of course, the lot size is always editable. We can move it around. We can add new points to it. And let's just reset that. And we can even import OBJ files in place of a shape. Let's take each floor, and I will import a car to replace each floor. So now we've got a stack of cars, all slightly randomly scaled differently. All right, let's take a look at some more complex examples. And these are all examples from CityEngine itself that I've been using as test cases. So here's a more geometric example, Urker, which has a sort of recursive aspect to it. So comp here is used to break up the shape into its constituent faces. Here I've chosen all of the faces, and it creates a new shape called Urker from them. And then the Urker shape recursively does another comp to break up its faces and just chooses the outward shaping face and applies Urker to it. So we get this kind of neat looking shape. Once again, of course, it's all editable. Doesn't need to be rectangular shapes. It can be any sort of shape. We can create interesting and fun shapes of various sizes. Let's try another one. Here, we've got something that is meant to simulate the look of an apartment block. We've basically taken the lot, broken it up into floors, and broken the floors up into apartments. There's a combination of texturing going on and some geometric modeling of window ledges. And once again, it's all editable. We can change the building height. We can change the floor height. We can take a closer look at these guys and move the various parameters around to define what the windows and frames look like. And it's kind of fun. Let's change the balcony size, make it much larger. There we go. So the previous Urker example was quite simple. This one is quite a bit more complex. It's got quite a few more rules to it, creating internally a fairly large tree of transformations. So anyway, that's about it. I've only implemented a small part of CGA Shape Grammar, but it's enough to have a lot of fun with. So I hope you've enjoyed my demo. It was a lot of fun to write, and it's a lot of fun to use. Thanks for watching.